All right, let's look at Newton's method. So Newton's method is actually very, very easy. All you need to do is you need to be familiar with this formula. Now it might seem a little bit difficult, but it's very easy. Okay, look at this. X sub n just usually means x1. This n represents a 1 then, so it's going to be x1 plus 1. So to find x2, it's going to be x1 minus the f of x over f prime of x. Okay, what does this mean? Well, we need to do the following. We need to derive this original function. Okay, so if we derive it, we just bring forward 3 minus 1 minus 2 bring forward, that becomes 8x, and then we have minus 11. Okay, we have the original function. We have f of 10, or you need to look for this thing. You need to look for where they tell you let x sub 1 equal something. They'll usually tell you. Now the idea is we want to find repeating decimals, usually the 4th decimal. But I'll get to that in a bit. Okay, what do we do now? Well, now you have x sub 1, you have f prime of x, and you have f of x. Very simple. All we do now is we have x1, so we can then say x2 is equal to x1. x1 is given as 10, so we substitute for 10, and then we just simply plug in our equation. But now instead of plugging in my equation, I'm going to substitute x. Okay, very simple. Look, minus 4 raised to the 10. You just substitute your x sub 1. Okay, minus 11, 10 plus 30. Okay, that's my original equation. Below the line, as my denominator, I'm going to substitute x again, but this time into my prime function, okay? My derived function, okay? Very easy stuff. Look at this. And there you go. Newton's method done. Boom. Okay, I'm just kidding. It's not that easy. Now we're going to head over to a calculator. So what was that function? Let's see. So it's going to be 10 minus, would be better if you have a calculator. 10 cubed minus 4, 10 squared minus 11, 10 plus 30 over 3 times 10 raised to the 2 minus 8, 10 minus 11. Okay. So we have this value. So now we just calculated for x sub 2. So it's going to be 7.5116. Okay, so let's say x sub 2 is 7.5116, right? 559. Whoopsie. Okay, 559. Okay, so what do we do now? Well, now you can just do the following. You can take this answer, whatever you found here, and you can just replace it with every 10. Okay, on your calculator, you should have an answer value. So when I replace it, now I all of a sudden get 6.097, 6.029. So let's write that down. So therefore, x sub 3, because instead of using the 10 now I'm using the x sub 2's value, because remember, now I'm calculating for x sub 3. To calculate x sub 3, I need to put x sub 2 minus the x values. Okay, let's go back to that answer. It was 60297. So it's 60297. What, I feel like that's wrong. Okay, now I'm going to do it again. Going to replace every single x. This is all you do, rinse and repeat till you find some repeating decimal. Okay, usually 4 decimals that repeat. Okay, let's see, we have 5277, 5277. So therefore x sub 4 is equal to 5.277, 778. Well, I'm going to do it again now, because we're not finding a repeating pattern yet. Oh man, now I have 50294. Okay, I'm gonna continue going then. 5.0294. All right, here we go again. Okay, 5003. So let's continue over here. It's going to be 5.003. Seems like I'm closing in. I'm closing into what I want. Okay, 5.003. Guess what I'm going to do now? Haha. Usually the calculations wouldn't be this complicated. You'll find your repeating decimals after like the second try or the third try. I took the first random example I could find. Okay, here we have 5.00095. Okay, so x sub 7 is equal to 5.000 blah 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 7. Okay, there we have our repeating decimals. You see what's happening? We're closing in. Okay, now I can stop at that point because I know I've estimated approximately to the fourth decimal correct. So it should give me again repeating decimals. Let's have a look. Okay, now we get 5. So x sub 8 is then 5. And it's going to be 0, 0, 0, 0, 0. Okay, so what was the point of this? Well, the point is usually you want to find 3 or 4 4 repeating decimals. So in this case, it's showing that the approximation is going to be 5. But what will be expected of you is they might ask you, well, do this to the third ordered principle. The third ordered principle just means x sub 3. Or the fourth ordered principle, x sub 4. Or they can tell you, well, estimate the decimals up until the fifth ordered principle to the fourth decimal. That means 4 decimal slots, 1, 2, 3, 4. So this is what you ideally have to do in these type of Newton's method equations. So again, this is what we do. We get the f of x. They're given to us, or they give us the f of x. We need to derive f of x, and they will usually give us x sub 1. All you then do is you take this 10, you plug it into the f of x, and you plug it into the f prime of x. You get a new value. This new value is over here. Then rinse and repeat until you find what you need for, or what you're looking for. So again, the type of questions that can be asked is estimate to the third ordered principle. So third ordered principle, so x sub 3 to the fourth decimal. Or find repeating decimals. Finding repeating decimals that might be more university related would be something like this. Here we found our 4 repeating decimals. So we can safely then assume that our approximation is going to be 5. Okay, that's it.